Okay, let's just dive right into this explainer. We really need to start by validating that totally crazy, awe-inspiring feeling you get when you first use modern AI. You know the feeling? You type a super simple sentence into a prompt box, and literally in seconds, a machine writes flawless code, generates this breathtaking piece of art, or drafts an entire essay. It feels completely supernatural, doesn't it? Honestly, it feels like we've finally crossed the threshold right into a science fiction movie.
And because it feels so magical to interact with, it playfully begs the question, are there just tiny digital wizards inside your laptop wearing robes and casting spreadsheet spells? Obviously the answer is no, but we really need to violently pull back the curtain today and bust some major myths. You know, advanced science almost always looks exactly like magic, right up until we understand how it actually works. And the reality of AI? Well, it's grounded in something way more fascinating than magic.
So, let's get into Section 1, pulling back the curtain and the actual mechanics of the illusion.
To expose the gears turning behind the scenes here, we first have to squash this idea that AI is some giant, conscious brain just floating inside a computer server. It's not. It is entirely driven by algorithms, and an algorithm is just a set of mathematical rules the AI follows to find patterns in data. Think about it like a student studying for a massive exam. One student might use flashcards, another might prefer taking practice tests. Algorithms are really just different structural methods for finding patterns and learning from vast amounts of information.
So how does that build a trained system? It's basically a relentless mathematical three-step cycle. First, you input data. Second, the system makes a prediction based on its current mathematical weights. And early on in training, this prediction is practically just a random guess. But then comes step 3, adjusting the weights. This is a process known as backpropagation. Every single time it gets something wrong, it tweaks its internal math, so it'll be slightly more accurate the next time. It's exactly like practicing a dart throw. You miss the board entirely, you adjust your stance and your aim based on that feedback, and you throw again and again until you consistently hit the bullseye.
Moving right along to Section 2, how AI actually learns, which comes down to probability versus experience.
This highlights a massive, fundamental difference between us and the machine. Human learning is deeply rooted in conscious experience, right? We learn through our emotions, our culture, curiosity, childhood memories, physical interactions with the world. A musician writes a heartbreaking song because they've actually felt the crushing weight of heartbreak. Machine learning, on the flip side, does not experience life at all. It simply processes massive amounts of data, adjusts billions of mathematical parameters, and calculates probabilities. It's kind of like giving an extremely talented chef millions of recipes and asking them to invent something new. They aren't remembering warm family traditions, they're just combining ingredients using the statistical patterns they've learned.
I absolutely love this quote, because to put it simply, modern AI is basically an incredibly fast autocomplete system that has just become astonishingly sophisticated. Imagine your phone's autocomplete feature, went to graduate school, drank several gallons of coffee, and spent years studying billions of text examples from the entire internet. When it writes a poem, it isn't reflecting on its childhood. It's just predicting the next word, or the next pixel, based on learned statistical relationships. Astonishingly sophisticated, for sure. Conscious? No way.
It's also super important to realize this technology didn't just appear overnight, even though the current hype cycle totally makes it feel that way. Scientists actually began exploring machine intelligence way back in the 1950s with Alan Turing, and we went through these long decades known as AI winters, where funding just dried up and progress stalled because we didn't have the computing power or the data. It wasn't really until 2012, with the rise of deep learning and massive computing hardware, that things finally took off, paving the way for the generative AI we're all using today. So AI didn't just show up at your dinner table like a surprise guest claiming they invented sentient microwave popcorn. It's the result of decades of grinding, rigorous mathematical research.
All right, let's look at Section 3, the hidden human effort and the physical anatomy of AI.
We all have this habit of thinking about AI as this clean, ephemeral, independent thing just floating up in a digital cloud, growing all by itself like a digital houseplant. But the truth is much grittier than that. Behind every single magical prompt you type is a vast, invisible physical anatomy. Building an AI device requires deep earth mining for rare materials. We are literally extracting Earth's deep geological history just to serve a split second of technological time. It relies on massive, incredibly energy-intensive server farms, and honestly, most importantly, it relies on the immense, often drastically underpaid labor of thousands of human data labelers who have to manually categorize information so the machine can learn. Add in legions of security specialists, linguists, and engineers, and you realize AI is actually a deeply physical, deeply human-powered industry.
Which naturally leads us into Section 4, limits, flaws, and bias, and exactly why the machine is fallible. Because AI relies so heavily on all that human-generated data we just talked about, it inherits our flaws and our strict limitations. One of the most famous limitations right now is what researchers call a hallucination. That's when an AI confidently provides a completely incorrect answer. Remember, it's calculating probabilities. It is not querying some universal encyclopedia of absolute truth. When it makes a mistake, it's not because the AI is seeing tiny dancing calculators singing karaoke in its digital mind. It is just confidently predicting a string of text that happens to be completely false out here in the real world. We really have to remember that confidence does not equal accuracy. And then, of course, we have the critical issue of bias in the data itself. Think about it like this. Say you train an AI to recognize an apple, but 90% of your training photos show bright red apples and only 10% show green ones. When you show it a green apple later, it's obviously going to struggle. The mathematics running the AI aren't inherently biased or flawed, but the incomplete, human-curated data feeding into it absolutely is. It literally only knows what we show it, so if we give it lopsided information, the AI will just reflect and amplify those blind spots, which proves once again, it's a mathematical mirror, not an all-knowing wizard.
Okay, our final section, number 5. A tool, not a master, and why we need human oversight in the loop. Ultimately, what you really need to take away from this is that AI is not an infallible master meant to replace us. It is an assistant that absolutely requires our constant judgment. I mean, look at this quote. It perfectly highlights the total absurdity of trusting the machine blindly. Your captain today is an experimental toaster running artificial intelligence. Yes, pilots use autopilot systems to assist them during flights, and they have for years. But if the airplane ever announced over the loudspeaker that an experimental toaster was suddenly running the show, every single passenger would suddenly remember a very important appointment back on the ground and sprint for the exit. We still absolutely want an actual human in the cockpit making those final life-or-death decisions.
Actually, a great way to think about artificial intelligence is as an advanced power drill. It's not an independent decision maker. Throughout history, humans have always built tools to save time. We use GPS instead of unfolding giant, impossible paper maps. We use search engines instead of flipping through physical encyclopedias. Using a power drill instead of a manual hand screwdriver isn't lazy, it's just efficient. But the drill still needs a human to aim it, ensure it's safe to use, and decide what the heck we are building in the first place. AI works the exact same way.
Because at the end of the day, the technology itself doesn't have a conscience, and it doesn't care about the outcomes. It simply crunches numbers. And that is exactly why the most critical component of the AI revolution isn't the algorithm. It's not the neural network. And it's not the massive server farm. The most critical component is you. The smartest part of artificial intelligence is always going to be the human who knows how to evaluate its outputs, check its sources, and use it responsibly. So as we wrap up this explainer, I want to leave you with a pretty provocative thought. Now that the whole illusion of magic is gone, now that you understand it's really just math, data, human labor, and probabilities, how will you take responsibility for wielding this incredible tool in your own life? Keep asking questions, keep thinking critically, and remember that you are the one in the driver's seat.